Hello everyone. Thank you for joining us on today's webcast. My name is Dina Evans and I am the Marketing and Special Events Manager here at Looking Glass Cyber Solutions. Today's presentation is Assessing Targeted Attack Techniques. And our Looking Glass presenters for today's session are Alan Thompson, our Chief Technology Officer, and Dr. Jamison Day, our Principal Data Scientist. Just a couple things before we begin. I want to run through a few quick housekeeping notes regarding this BrightTalk webinar platform. All of you should be able to see on the right side of your screen there's a chat feature for questions. So feel free to submit any questions that you may have for today's speakers through that window. All of our audience members are going to be muted, so if you have any questions, you would have to submit them through that feature in the chat screen. We'll be sure and try to address all the questions at the end of today's session. If for some reason we have an excess of questions and we run out of time, we'll still address them. We will just contact you directly following the presentation to make sure that you get your questions answered. We do also have a few links that are available in the section that says attachments and links, so feel free to peruse the items that are listed there. Otherwise, I'm going to go ahead and pass this over to Alan Thompson, who will kick off today's webcast. So Alan, it's all yours.
Thank you, Dina. Welcome to the webinar. I appreciate everyone taking the time to listen into the webinar today. As Dina said, assessing targeted attack techniques is something that we would like to cover on the presentation today. Now, most security professionals who are aware that there's lots of threats out there, which threats are targeting their organization or their specific environments versus attacks that are just in general in nature is something that we focus a lot on at Looking Glass. And one of the things that we've considered is really starting to consider what are the requirements for addressing or identifying targeted attacks and how to protect both our own organization as well as our customers that are using our products. So as a baseline, one of the things that we consider for both our own organization as well as helping our customers is what are the things that they are trying to protect from targeted attacks. So as a defender, what are the systems, the data, etc., that you want to make sure are protected against targeted attacks? So you may be trying to protect data, you may be trying to protect people, you may even be looking to protect physical environments, such as the buildings, the security systems that are providing physical security to your buildings. You may even be looking to protect more amorphous concepts such as brand. Now, depending on what you're trying to protect drives both what information you need to collect, but also how you apply that technique or that targeted attack detection technique to those aspects. I'll give you an example. If I was an energy organization, energy company that's protecting a power plant, and I may have control systems that run specific operating systems, specific applications, and I want to make sure that malware or a targeted attack is focused on compromising those control systems, there may be specific indicators or specific aspects of that attack that we would want to identify. That would be necessarily provide us with information to respond to those attacks, attacking those control systems. Now that may be a completely different set of information if it was a financial institution trying to protect, say, a rogue application or protecting an application that we use with our consumers accessing our financial data. So ultimately, what threats you're trying to protect against and what they are targeting really informs how you respond to targeted attack. The other aspect of what is also who is impacted by targeted threats. So for example, if a targeted attack is going after an executive and trying to compromise that executive, either to embarrass them or potentially get their credentials so that they can then do other types of attacks against the organization, the approach in how you protect that executive versus, say, a cyber team or a physical security team may be different. And so therefore, we need to consider these requirements as we consider assessing attacks. The other aspect of threats that we're faced with is that the diversity of how bad actors are considering targeting victims has expanded. You know, as the Verizon report shown on the screen right now shows, the approaches to breaching systems and environments is continuously evolving and increasing. So as a defender and an organization to defend against those types of approaches, we need to expand as well as potentially automate our ability to respond to them. An example might be the applications that are used in our environment. So, you know, as the Cisco report shows, that each different vertical has a high number of, about a third applications in each of these segments that are high risk. If I'm in one of these segments, I have to be focused on how do I protect that asset or that application if that is going to be used by bad actors to compromise my environment. So both what, who, and the threats that we're faced with all influence the requirements and the approaches to responding to targeted attacks. Now, if it was as easy as just adding more people, then clearly this chart shows that that is a problem. The workforce that we have today is overtaxed already, and we need to consider more automated means to be able to identify target attacks as well as the data that we need to collect. And that means that we need to be looking at automation. An approach to addressing targeted attacks can't just be developed in isolation. You need to consider how it fits into the overall flow of your response, your threat response capabilities. So not only do you need to consider the requirements, as I stated earlier, but how do you turn the data, for example, that you collect, what systems you're collecting it on, how you turn that into an analyzed and vetted data that ultimately can be turned into actionable intelligence that responds to threats. So you need to be considering not just algorithms or specific systems, but an entire workflow that starts with the requirements to the data, to the systems to be able to make it relevant, actionable, and valuable to your environment. Now, if you've done this, which many organizations have elements of that cycle that I just showed, clearly there's improvements around time to detection. With targeted attacks, particularly, but also in general, we're seeing improvements across the industry, as evident and reported by the Mandian report as well as Cisco's research, that the time to detection to malware or threats is improving. However, it's insufficient or not enough. And so therefore we need to consider what approaches to automate and identify targeted attacks. There's three areas that we would like to cover today. One is, what data do we need to collect? What data do we need to analyze and customize to make our response better? And ultimately, how does that interface with mitigation systems when we are being targeted? So let's start with collection. One of the first things that most security professionals want to do, and often is difficult, is get ahead of threats. So rather than being reactive, they want to be more proactive and informed about what to protect against before it actually happens in either their specific environment or the systems that they're protecting. So they may consider looking at threat intelligence data to inform them about the types of vulnerabilities, the TTPs, the indicators that bad actors are out there using to target either their systems, their industry, etc. So as you consider gathering data, you need to be looking at the rich context that threat intelligence can provide. It's insufficient to just gather indicators such as an IP address or a domain. Without context and background as to what that information is relevant to, it's really very hard to action it in your environment or consider whether it's targeting you or some other environment that's not relevant to your systems. The other aspect, back to my earlier point about what you're trying to protect, is where you gather information from. Does your threat intelligence cover elements of the surface web, dark web, social media? Does it allow you to ingest both human and automated information as well? So if, for example, a bad actor has created malware, is selling that malware that targets either the financial sector, or if you're a financial organization targeting you specifically, are they shopping that malware in a dark web forum? If you're available or have access to potentially some of that information, then you can potentially start to understand threats that may be coming towards you before they occur. So the more visibility and breadth of your capability to gather this information, the more in front of threat you can get. The other aspect is how timely the data is. When you consider threat intelligence collection and correlation, there's different aspects. Domains that pop up and then are used for phishing attacks that are potentially used to compromise credentials or gather credentials, they can occur within a matter of hours. If you're not gathering that data on a much more frequent basis, such as hourly, say you're gathering the data every few days or every week, then that may be insufficient to protect you against those targeted attacks. So when you consider threat intelligence, you need to be considering all of these aspects: what context you get, the coverage, and also how timely it is. Another aspect of identifying targeted attacks is not just the threat intelligence that is available externally, but also what information do you have in your own environment and your own assets and capability. So there's a couple of different approaches. One is gathering flow or session information. In terms of flow, the ability to correlate session information with threat intelligence and other behavior is useful, but it is not necessarily going to be sufficient because of how it typically is deployed. It typically is deployed in an aggregated manner. It allows you to do more historical analysis and potentially be able to identify behaviors over a longer period of time. But ultimately, it may not be able to help you on a per packet basis and make decisions. So Jameson, will cover some of these details in more depth later on in the presentation. But flow correlation is absolutely something that can help inform, but it is not necessarily sufficient. Another key point that we would like to point out is what type of flow data or session information you gather. If you only collect flow data between your systems and the internet, i.e. north-south direction, then that may be sufficient for identifying infections that have already occurred or transport of data across the perimeter. But if you're looking to identify how malware or behaviors cross your enterprise or cross your inside perimeter, then you need to consider how you gather those flows on the east-west traffic as well. And it's really important, if you're trying to do behavioral analysis, that you gather unsampled flow data, not flow data. Sorry, unsampled flow data. And the reason why that is oftentimes if you're sampling, you may only see one part of a conversation, and therefore you're unable to identify what is the true intent of that communication, and therefore you are left limited to the understanding. Another approach that is important is doing per packet correlation. The challenge with per packet correlation is obviously that you have limited time before you have to decide to forward a packet. So imagine, if you will, firewalls or IDSs where you're doing a packet inspection, you're capturing or deciding based on signatures of that packet what to do with it to forward it. That is typically, a level of inspection and correlation that can be done, but you don't want to impact the network throughput significantly, and so therefore it limits your opportunity. But it's definitely an approach that you should consider. Now, algorithms that look at targeted attack need to consider the organizational posture. So for example, what systems are you going to protect? So as you develop algorithms to detect targeted attacks, they need that input or that awareness. Without that, they're going to be having limited value. The second part of the algorithms that you need to consider is how you identify what compromised assets are out there. And that goes back to identifying behaviors or communications that are flagged to require further investigation. And secondly, once you've identified compromised assets, how do they communicate with the internet, and what indicators are important to extrapolate so that you can then respond to the attacks. Similarly, with communications going back and forth to the internet, you also need to consider what information has been exploited or compromised in the internal environment. So the algorithms that you're developing to identify target attacks need to be aware of the environment. They need to be aware of all of the communications as much as possible between your environment and compromised systems. And they need to be aware of behaviors that are assumed to be correct and which ones are bad. Those elements of the algorithms need to exist if you want to identify target attacks. One way that you can potentially help those algorithms be more effective is to consider tuning data that goes into the systems, such as your threat intelligence. So if you're able to identify sources of threat intelligence and determine which sources are accurate or more actionable than others, then be able to do that will influence and provide better results. Similarly, classification of data. So if an intelligence source is providing you many different types of threat intelligence, such as C2, botnet information, spam information, etc., you may choose to tune how that different data is classified so that more serious threats that are relevant to your environment are treated differently by the algorithms and therefore more actionable in your environment. The ultimate goal of tuning data here is to be more specific to your environment and the threats that are specific to you. That's a key part of making it more actionable. Another aspect that you may want to consider is learning from threats that are attacking sectors that are in your environment. So for example, if you're a financial organization, you may look to what threats are targeting peers of your organization, what types of malware would go after systems that you typically would have in your environment. Be able to monitor that as a whole will inform your decisions more effectively for your own specific environment. So being aware and collecting that information and being able to make it actionable in your environment will ultimately help you be more secure. So putting this all together, before we step into some of the more detailed information on correlation techniques with Jameson, you want to consider what systems you're trying to protect. You want to consider who those systems are used by and how to communicate with them, and what data you need to collect. So threat intelligence information you need to collect. What information do you need to collect on network assets? You then correlate that. You combine it with both human as well as automated means to then mitigate the actions in your environment. And with that, I will hand over to Jameson to go through more detailed correlation techniques. Jameson?
Yeah, thanks, Alan. Sorry, I had to take myself off of mute there. We will be looking more deeply at the different approaches to threat correlation. With that, though, I want to provide a little bit more rigorous definition of what threat correlation is. When we talk about correlation of threats, we are not talking about statistical correlation. In statistical correlation, we are typically looking at two different variables that change over time, and we want to look at how those fluctuations in those variables are related to one another. That is not what we are looking at here. What we are looking at here is threat correlation is identifying new insights by associating threats from multiple data sources. So as Alan was talking about, we want the threat intelligence and we want the network activity, whether that be flow data or packet data. And we want to look at the intersection between those two. What do we know about the current threats? What do we know about our current network activity? and how can we look at the intersections between those in order to identify the threats that are targeting us in attack right now. And that's the focus here. So we're going to examine various different approaches to threat correlation. We'll look at manual threat correlation, the use of several different automated capabilities, such as field comparison, rules-based matching, fuzzy matching, and then what everyone seems to be talking about right now, and that is machine learning. We'll dispel some myths there and talk about what the strengths and weaknesses are. So let's jump right in and talk about the kind of correlation that has been done for many years now, right? Humans have always been a part of this process of threat correlation, and there's a lot of good reasons why that is. When you've got multiple sources of information and you want to look at the patterns that are common to both of those sources or to multiple sources, there really is nothing better than getting human eyes on the problem for being able to distill new intuition and new knowledge out of that. Humans have various advantages: pattern recognition, language abilities, creative thinking, flexible inference, and their intuition and guessing, led by kind of well-informed biases. They're unmatched. We can't program to the level that humans are capable of identifying these correlations today. However, humans are not very fast when it comes to step-by-step instruction execution. If you have a solid process, something that can be automated, the human is not going to be able to keep up with the computer. And so we're turning more and more to computers and automation capabilities in order to process the large amounts of information that we're churning out. Humans also have a drawback of being rather unpredictable. What one analyst might look at and see a correlation in, another analyst might look at and not. And then sometimes the same analyst may not see it presented with the same information later after they've been looking at other things. And so the biases and prejudices, while the well-informed ones can lead us, can lead humans to identify insights that are fantastic, those similar biases and prejudices lead us into some drawbacks of not being able to reproduce or create the right type of intelligence, kind of fused intelligence coming out of this process. That said, we need our humans, and here at Looking Glass we have a threat intelligence group that consists of over 80 security professionals. They speak more than 50 languages amongst themselves, and we do offer several services, including threat analysis that fills gaps in our customers' intelligence operations, threat intelligence operations. We do a lot of response and takedown where we eliminate rogue application, data leak, phishing, fraud, copyright violations very quickly for our customers. And we have a special investigations unit. This is where the intelligence investigation goes when things are beyond the scope of the normal, and we really need to dig in deep. And so the reason why we have these human beings, very talented human beings doing this, is that our automation can't do everything. And we want to be able to generate new information that we can maybe feed into our automation. And it's that feedback process of continuous improvement that allows us to innovate greater automations that help assist our humans, and humans finding new insights that help us improve our automation. So with that, just a little bit of background on why it's essential that we start augmenting these human capabilities. Today, it's not uncommon to see one network asset, one computer, initiate between 3 to 4 network flows per second. This is not even talking about packets. We're just talking about network flows here. Each of those flows could have multiple packets. But in terms of flows, that one asset over an 8-hour day will generate 115,000 flows. If we have 1,000 networked assets in our organization, now you're talking about 115 million flows. And if we only assume that 30% of that is northbound, southbound internet traffic that goes outside of the organization, that cuts us down to 35.5 million. Let's say that only 5% of those flows are actually related to some sort of threat intelligence association. So now we're down to 1.8 million. If we want to prioritize and look at only the elevated threat scores, maybe above a 75 out of 100, that may pose some more significant threat, then we're down to 180,000 flows. You can see that that's more than any one human being or even a small team of human beings is going to be able to effectively analyze in the course of a day, an 8-hour day. So it's critically essential that we move towards automating and augmenting our human processes with algorithmic computational capabilities. And so that's what we're going to look at here. What are the automated approaches to doing threat correlation? So perhaps the most simplified version of threat correlation would be field comparison. There we're just identifying features that are seen in different data sets, specific fields within those data sets, and we're going to be able to do a quick match on those. It's very simple, very fast, very scalable. You can distribute this rather easily in kind of today's clustered computing environments. And it's a great way to start getting some quick results. It is a naive approach. This will miss some more sophisticated attacks, and we'll talk about the strategies that various threat actors use to confound these approaches a little later in the presentation. So field comparison, very simple, very fast, very scalable. Not the best, but a great way to start out. Rules-based matching is kind of stepping it up a level from the field matching. And here what we're doing is we're not necessarily looking for the match between two different data sets, but perhaps one data set is providing us with signatures that we can look at within another. A lot of times this can be used in network packet assessment for threat correlation. We can identify very complex interactions. We can look at complex patterns of characters or complex patterns of bits and bytes that are coming across. It is scalable. We can partition this out in a distributed environment as well. However, this does have some drawbacks. You know, the more rules that you create, the more signatures that you're trying to detect, the larger the list of rules that you have to maintain, modify, purge, and then add new threats in. And so those new rules can be very cumbersome to manage, the large list of rules. Now, that being said, we actually do both of these here in Looking Glass. We have a series of threat mitigation appliances that do many of these activities using the threat intelligence that we bring in. For example, Net Defender, there we are going to look at any of the north and southbound activity in a network, and based on the threat intelligence, phishing sites, malware sites, command and control sites that are active in our current threat intelligence, we generate rules for Net Defender to, we feed those fields to Net Defender so it can do field comparison and very quickly look for things that look like they're part of phishing, malware, or command and control activity so that we can eliminate those. We also push packets off to several NetSentry appliances that can do packet-based inspection with rules-based matching of threat correlation. So there we're taking all of the signatures, snort signatures that we generate based on threat intelligence, active threat intelligence, and NetSentry is constantly looking through packets at line rate in order to identify any activity that looks like it might be related to various threats. We also have a DNS Defender, which is primarily looking at command and control communications that utilize DNS, a very difficult thing to protect against. We've got some solutions there as well that help your DNS infrastructure stop known command and control communications for various malware. So here you see we're integrating these automated capabilities, and behind all of this we have human beings that are making sure that they're doing the right things. And so that's the key, is getting your automation and your human-based activities for threat correlation working together in a way that provides value to your organization. Now, if we continue down the rabbit hole of more complex approaches to threat correlation, we can move into a realm of fuzzy matching. This takes your rules and actually allows for deviations from those rules. This can help identify complex interactions and new tactics that threat actors may be using. It does capture those minor changes of malware that might be evolving and giving you some early warning on things that might be changing in their attack patterns. However, the drawbacks here are that the fuzzier you allow these matches to be, the more false positives you're going to generate. There's going to be constant need for feedback and refinement of the fuzzy matching. It can be very computationally expensive. Looking for all possible variations on a rule can take a lot more time. So this is not something that you're probably going to be able to establish and do at line rates. And finally, the last approach that we're going to talk about today is the use of machine learning. There are a wide variety of different techniques in machine learning, and typically with something like threat correlation, we will use various forms of machine learning classification, clustering, or neural network approaches in order to identify correlations that maybe our humans aren't seeing and maybe the other automated capabilities aren't catching either. There's some beautiful opportunities with machine learning to be able to identify and learn new tactics. However, one of the biggest drawbacks, I think, with machine learning is that this does not help build intuition. A lot of times the machine learning algorithms are going to provide you outputs that provide new things we might not have seen before. However, they don't provide you with the intuition for why they're important. We still need the human beings to go see and investigate, why did this get kicked out of our system as something unique, as something that we need to look at. And once they learn why, which the algorithms can't tell them why, when they identify why, then we need to build that intuition into our further processes of refinement, not just for how humans approach the data analysis, but also for how our automated solutions approach the data analysis. And so these machine learning efforts are great for continuing to refine our capabilities, but they also have some drawbacks that are not easy to deal with or explain, especially within a business context. That understanding has to be ferreted out by others. It's not scalable. They're very slow. Typically, these efforts run separate from the line rate or the real-time mitigation efforts. And it is very tough to tune the false positives and negatives. You may spend your time, your humans have to spend more time running down rabbit holes without rabbits in them in order to find the new, identify other ones where the new insights might be very useful. That said, I promised we would look at how hackers can evade the various types of threat correlation. And here's a fun table to give you an idea of how much effort we're putting in versus how much effort the attackers are going to have to put in. With manual threat correlation, the level of effort is pretty low. We hire more humans. But if we wanted to evade detection there, we could just increase the amount of traffic and overwhelm those humans. Our organizations are essentially doing that themselves. The larger our organizations, the more network assets we have communicating in our organizations, the more network activity we are generating, and that becomes very difficult to deal with. With field comparison, many attackers have started rotating their use of unique identifiers. They'll switch IP addresses, they'll switch domain names, and that allows them to evade detection and field comparison. You heard Alan talking about the use of phishing schemes where maybe the registration of a new domain is used within the first 6 hours to start doing all kinds of threat activity. Those attacks, if we can't get them and roll them out right away, it's very difficult for us to catch up with those rotations that the threat actors are using. With rules-based matching, not only do you need to rotate the use of unique identifiers, you'll also need to have slight modifications to your tools. And certainly we have seen in the industry, threat actors are using all kinds of automated tools to very subtly mutate or evolve the tools that they are using so that they can evade detection through these signature-based matching capabilities. Fuzzy matching is very similar to rules-based matching. However, it's going to require more significant modifications to the tools that the threat actors are using. Much higher level of effort there. They're going to have to go back to the drawing board each time they want to do a new attack with similar tools. Machine learning gives us the possibility of being able to look at even those more significant modifications to the tools. If they're still using the same attack vectors, but just modifying their tools significantly, the machine learning may give us an opportunity to see those things and may require our threat actors to continuously change their tactics at a higher level. So again, it's harder for us to implement those solutions, but it's also making it harder on our threat actors to continuously change what they're doing as well. So let's talk a little bit about value for these. If we can assess these targeted attacks, threat correlation allows us to do that in a way that basically helps our organization to identify the active attacks. If we start identifying the active attacks through correlating our threat intelligence with our network activity data, we can then assess the attack severity. Alan talked about tuning the threat intelligence data so that we know what are higher threats and what are lower threats in our industry or to our organization. We can automate the process of assessing that attack severity. And based on what we know about the value of our systems, we can then prioritize where we place our response and mitigation activities. We have a limited amount of capacity and resources for doing those response and mitigation activities. So it's very important to be able to decide quickly where we put those in order to limit the amount of damage done to our organizations. And then finally, threat correlation can also help us identify where those new threats and new anomalies are occurring, so that we can see how things are evolving over time. This is a learning process, and we have to make it a part of a learning organizational model for continuous improvement. To that end, we provide several recommendations for your collection efforts, your analysis and customization efforts, and your mitigation efforts for your automated threat response. So number one is to determine which threat intelligence feeds are best for your organization. Integrate that threat intelligence into your automated threat response as you can. Enrich and analyze your network activity. And finally, automate as much as you can the correlation of that network activity with threat intelligence. But as I've said a couple of times already, ultimately, to maximize your impact, you need to figure out how to make those feedback loops within your organization so that your continuous improvement not only improves your humans' intuition and their capabilities, but also your automated tools for assessment and threat detection. Those targeted attacks are not going to stop, and they're going to change. We need to change with them. So with that, I think we can open up the floor to questions at this point. Go ahead and type in any questions you have. And I think, Dina, I'll hand it back over to you to moderate the questions.
Yeah, thank you, Jameson. It looks like there's a few that have come through. Here's a good one. It says, and Jameson, I think this might be more for you in your bucket, but it says, what are some key challenges with using threat correlation? Would you like to address that one, Jameson?
Certainly. One of the big challenges that we've seen is, we've seen many big challenges, but one of the big ones is threat intelligence quality. What is the quality of the threat intelligence that you're bringing in, and how can you make sure that not only the threat intel, but that the network activity that you're putting into the system is going to give you good outputs. You know, we all know garbage in, garbage out, but how do you make sure that you're getting the highest quality in a way, in a format that can actually drive your automated threat correlation capability? Once you've got that good data, and that's not a trivial effort, but then you need to start tuning your false positives and your false negatives. There will be alarms that go off, false alarms that go off, and you will miss some alarms that should have gone off that did not. Ultimately, though, you know, the organizational challenge of integrating those issues into the broader cyber threat intelligence management processes of your organization are also a real challenge. And then finally, I would say that, you know, there are also some organizational policy issues around collecting network activity, and having your organizations and your legal folks look closely at those issues is another key stumbling block, a challenge to using threat correlation effectively within your organization.
Awesome. Thank you, Jameson. Here's another one that's come in. This one says, what drove the requirement of threat correlation? Who would like to address this one?
Alan, do you want to take a crack?
Sure. So what drives threat correlation? Well, I think ultimately, you know, as I said right at the beginning, you know, people who are trying to protect their environments, ultimately they're trying to protect the systems and the people and the things that they're responsible for. And threat correlation is really about gathering evidence to support, you know, defending those assets. So the more information that you can correlate and ultimately have outcomes from, the more likely you are to be able to protect or at least reduce the risk. So it's really about what drives requirements around threat correlation is what information can be inputted and ultimately outputted to drive risk reduction in your environment. So the more that you can gather, which specific systems you use, applications, etc., the better your risk awareness is there. Secondly, responding to the risk, what systems need to be in place to actually mitigate. So consider not just what information needs to go into threat correlation, but also what information needs to come out of threat correlation to inform mitigation action. So consider it a process of both inputs and outputs, and that really drives what is ultimately why you're developing threat correlation.
Thank you, Alan. Here's another one for you gentlemen. If I had to choose one method, what is the most effective threat correlation approach? Jameson, I think that one's probably for you.
Yeah, that sounds right up my alley. You know, that's a tough question because it really depends on context. You know, depending on your organization and what kind of threats, targeted attacks you're seeing, you know, as we've seen, the different methods for automated threat correlation are, they have different strengths and weaknesses. You know, I would say that if you don't already have a manual capability for threat correlation, you'll definitely need that as a foundation. But assuming that you've at least got someone that can, or multiple people that can do some of this threat correlation between threat intelligence and network activity, I would say your next biggest bang for the buck is just moving into a very simple field comparison threat correlation. With that, and Looking Glass has just recently rolled out a solution called Scout Shield, which automates a lot of this process for our customers. We vet several threat intelligence sources, and we generate a roughly 99.9% accurate feed of information, of intelligence about which URLs, which IP addresses to to make sure that our organizations, our client organizations, are not communicating with. And so it will effectively block that. So it's behind a firewall and automatically updates a lot of those policies. And so that is a very high value method, low effort, high value method for putting threat correlation into your organization. But again, I would always recommend that you have humans, some human threat correlation capabilities behind that to help make sense of what's coming out of that. When there are issues that are fired out of that system, someone still needs to be able to mitigate and respond to those efforts. So, Alan, anything to add on that?
Yeah, no, I think that's an excellent point. Ultimately, what is actionable in terms of threat intelligence is really evidence-based. The more evidence you have and how you collect that evidence that this represents 100% accurate information to act on, the better it is. So if you have multiple sources corroborating information or data that needs to be acted on, that's great. If you only have one source, then how is that source determining the accuracy of what they're seeing? Are they standing up a sinkhole where they're actually part of for example, a botnet command and control server, and they're therefore absolutely certain that what systems are communicating with them are actually infected by a botnet and looking for command and control instructions from the server? If you have such a capability or a sensor providing you that information, with certainty that that is information that's actionable. But there are other forms of information data gathering that may be not as confirmed, and therefore you would look to additional sources of information and additional context before you would want to act on it. Because obviously, as Jameson has said, there's only so much you can do in terms of automation, and what you want to do with automation is raise it up to the analyst to then decide, does the evidence support action? And that's where an analyst's intuition and experience will come to play to be able to action on it.
Yeah, great point.
Thank you, Alan. Here's another question that's come in. It says, what are some of the benefits around threat correlation that every organization should see? You guys want to take a stab at that?
Sure. We talked about how threat correlation can help you identify what are the targeted attacks that are active in your system at this time, right? Hopefully as they're occurring. Assessing that attacks, the severity of those attacks is something that I think, as Alan talked about, being able to tune our understanding of what threat intelligence is relevant to our organization can be brought into that automated process of threat correlation so that we can assess severity of the attacks. That in addition to the value of the different systems that are being affected, can be brought together into an understanding of where our response and mitigation activities should be prioritized. And then, finally, hopefully being able to learn about new threats and anomalies as they evolve. Not only, the things that are attacking us, but also we might gain insights into broader threats that are evolving through the evolution of different threat intel as well. The benefits, what is the return on investment? Depends on your organization, and it depends on the threats that are facing your organization. But I think there is a way for us to be able to see not only the value of what we are putting at risk in terms of financial exposure of our data, of our systems, of our network assets, but also in terms of what is the return on investment then for our resources that we are bringing in to do cyber threat management. Where do we see the return on investment from bringing on one new human being? Or where do we see the return on investment from bringing in a new system? How has that changed our financial exposure to the threats that are existing to us, the targeted attacks that are affecting us in the industry, in our context right now?
Fantastic. Thank you, Jameson. It looks like there's a couple more that have come in that are wanting some direct response, so we will reply to you guys directly on these as soon as we wrap up the webcast. And I think we're just about out of time. So in closing, I want to basically thank Alan and Jameson, both of you, for today's insightful presentation. We truly appreciate your expertise. And I want to thank all of you that attended today's live webcast from Looking Glass. A recording of today's webinar will be made available on our website under the resources page for additional viewing. Feel free to share the presentation with your colleagues, or if you happen to join us a little bit late, the full recording will be available. There's a direct link on our website to it in the Bright Talk page, and also, as you can see on this last slide here, our website itself is lookingglasscyber.com. You'll also have access to our other recorded webcasts that are available on our site as well. If you have any additional questions for our panel of experts, or if you'd like more information from the Looking Glass team, feel free to contact us. There's a contact page on our website, or you can also contact us directly at sales@lookingglasscyber.com. But again, thank you very much to Jameson and to you, Alan, on today's presentation. And if you gentlemen, do you have any additional comments before we wrap up?
I just wanted to say thank you, Dina, thank you, Jameson, and thanks to the audience for attending the webinar. Appreciate taking the time to listen to our presentation. Thank you.
Gratitude. Hope it's helpful.
Absolutely. Thank you, gentlemen, and thank you to everyone viewing. Thank you.
Thank you.